Good afternoon, everyone. While we're waiting for other students to join in, if you have any questions, please put them on chat. Worksheet number 1, yeah. Cindy, which problems? Or Leah, it doesn't matter. Cindy, which problems? All of them or specific ones? Okay. All right, so we're gonna do a number 1 and then I will pick up Leah's question. I will not do all of them, of course. I will do A and I will let you struggle with B and C, okay? So number 1, the question is to find a formula for an exponential function that satisfies the given condition. All right, so it means we have a function, we don't know the rate, the growth rate or anything, but we have 2 data points as we did last time, and the question is to find a formula that fits this data. So that's A from the worksheet. Okay, which is this one that you guys have it on bright space. And the question is find a formula for the exponential function satisfying the given condition. At 3, it's 3 over 8, so I'm going to write this down. So f of 3 is 3 over 8. And at 7, the function takes the value 12. So, sorry, I need to mute everybody because there is noise. So, and f is exponential. It means we know the formula for it. So basically, this is what we're talking about. We have a function. I don't know the growth rate. I don't know the initial value. I have 2 data points. So at 3, means if the input is 3, the output is 3 over 8. So somewhere in here. So that's one value. And at 7, it means if x is 7, it's 12. So it's really somewhere up here, very high up. Okay. And this function is exponential. It means the graph is not a line. It does not grow by the same amount. Okay. And the problem is to find a formula. Okay. So first we start that the idea is that f of x is a b to the x. So that's really our basic. And now we're going to use those 2 data points to find a and b. Okay. And that's the idea. Find a and b. Okay. All right. So let's use the first thing. The function takes 3 to 3 over 8. What does this mean? Means that if I plug in the value 3 for x, the output is 3 over 8. Okay, that's how we interpret. It takes 7 to 12. Means, so the function takes 7 to 12. Means if I plug in 7 for x, my output will be 12. So one way you can look at it, this is a 3 here. This is a 3. So one way you can look at it is that you have basically 2 equations, this one and this one, and you have 2 unknowns, 2 things you don't know, the a and the b, and you have to use them both to solve for a and b. That's how you can really look at the problem. All right, so remember the trick we used last time. Who can remind me the trick? What did we use last time? What was the approach we used last time to be able to figure this out?
We took the higher number and then we divided it by the lower one. So it will be like a times b to the 7th over a times b to the 3rd.
Yeah.
Equals 12 over 3 over 8. My
Right,
bad.
that's exactly what we did. And as I remember, I told you the reason we did that. The reason we did that is that now we can simplify by A and isolate B very carefully. But now we have a little bit of math to do. If you have B to the 7 over B to the power 3, this gives me B to which power? It means how many B's are left? 7 minus 3. This will give me B to the power 4. Okay, so this will give me B to the power 4 equal. This is 12 over 3 over 8. Remember that this is a fraction. It means it's 12 times 8 over 3. Okay, because dividing by a fraction, multiplying by the reciprocal. So now we can do a little bit of math. So B to the 4 equal 3 and 12. So we can simplify because 12 is 3 times 4. The 3 simplify, and I will get 4 times 8, which is a 32. Okay, now we get to the B. If B to the 4 is 32, B is the 4th root of 32. Am I right? If I do a mistake, it's your problem. You guys have to correct me. So what is B equal to? So what's the 4th root of 32? It's not a very nice number, actually. So we're going to take 32, evaluate it to the power 1/4, and I'm getting 2.378. That's my B. Now I need to find the A. How can I find the A? All right, I have 2 equations. Now I know the B, and I have 2 equations. I can use any one I want to find the A. It doesn't really matter. Regardless which one you use, you're gonna get the same value of A. I can use the top, or I can use this one. You have total freedom over that. So suppose I use this one. It means I will have A. So now we need to find the A. Okay. A times B to the power 7 equal to 12. It means A times my B is 2.378 to the power 7 is equal to 12. Now I need my A. So we can divide both sides by that to the power 7. And then I just basically pick up the calculator and evaluate. So I need 12 divided by 2.378 to the power 7. Okay, so I'm getting 0.0279. 0.0279. Okay, so what's my function f? It's going to be, that's my A times the B to the power x. And my B was 2.3718. Okay. Questions before we move on? Any questions? Okay, Cindy, does it make sense? With me? Okay. All right, so now we're going to do one more. Actually, so those 2, B and C, are along the same line. I strongly urge you to do that. And I'm going to look at number 2, 3, and then I will move on to the other questions you guys are addressing. So number 3 is the same idea. So I want you to pick up a piece of paper yourself and do it and give me the answers. But with this like a story attached to it. So we have P of T is the population of a country in millions, T years after 1990. With P of 7 equal 3.21 and P of 13, 3.75. It means that at T equal to 7, means in 1997, the population was 3.121 million. So the census was done, not in 1990, the census was done in 1997. And then it was done for T equal 13. So after basically 6 years, and the population grew. Another question is, find a formula for this population, granting it is exponential. Well, so this is basically the same problem as before. So we have the input is time, output is population. After 7 years, the population was 3.21 million. So I keep 3.21, but my unit is million. And after 13 years, so the population grew to 3.75. So my graph at 7, at 13 here. And the growth is exponential. It means not by the same amount, by the same percent. So that's really my graph. Another question, what's the formula for P of T? So it's again the same idea, exactly the same. So let's do that very quickly. I will ask you for answers, so please be ready. So we know that the population is following the pattern A, B to the T. Now I make use of the data. Equal 3.21. It means if I plug in 7 for T, I get 3.21. And then after 13 years, I mean, in 2003, it means 6 years after 7, the population is 3.75 million. So these are my equation now, and the question now is to find AB. So by now, the mechanic is simple. We divide them by each other to get the A. And we use the highest power because the problem will be much simpler with the highest power first. So I get that equal. This is equal 3.75. And this will be equal to 3.28. Sorry, 21. And the goal, as I said, is we get rid of the A and we isolate the B. I give you a minute, all of you, and then I want the answer. What is B? So while you're doing it, I will do it myself. I want a B on chat. I will not do it. I want you guys to give me the B. And all of you are responsible, not only the few. Give me the B. Okay. All right, anybody else? So I'm getting an answer. Anybody else? Give me the answer to 3 decimal places. So I want the answer up to 3 decimal places. Okay. Anybody else? Okay, Jessica, all right. We're agreeing so far. Anybody else beside those 2? Okay, Brianna, all right. So me, everybody agrees. So you guys must be right if you all agree. So let's do that. B13 over B to the power 7, we take away the power. Give me B to the power 6. It's 13 minus 7, which is the 6. All right, equal. Now 3.75 over 3.21, I don't think this is a nice number. So we can evaluate it. Because it's not really a very nice number, I'm getting 1.168. 168. So now I need the B. I have B to the 6. To get the B, I have to compute the 6th root. Okay, and evaluate that. And according to everybody, we're getting 1.026. And I think everybody is correct. So that's my B. Once you have the B, you have the A immediately. You can use this equation or this. You are free to use each one of them. Regardless which one you use, we will get the same A. So let me use the first one. Now we're going to find A. All right. We have A, B to the 7 equal 3.21. Now I plug in the value of A here. And then I isolate my A. We isolate it by dividing by this term. And then I don't know how much did anybody did it? And give me the answer to that. Do it and make sure we get the same answer, all of us. Uh, 2.682. Okay, all right, let's do it together. That's 3.21 divided by parenthesis 1.026 to the power 6. That's how I am inputting it. And then 2.75. Oh, well, I'm getting something different than you. Oh, to the power 7. Okay. Divided by 1.026 to the power 7. We're getting 2.682. You're absolutely right. 0.682. All right, so from the two data points, we know that the population would be given by the following formula: 1.026 to the power 3. So that's the formula for the population. So we have the population at 2 time, different time. Now I have a formula for the population at every time, granting that it is an exponential growth. Now question number B is the following. What's the initial value and what's the growth rate? So now that we have a formula for the population, I know what's the initial value is. It means in 1990. And what's the growth rate? It means this population is growing. And by what percent it's growing every year? Okay, so now I can answer this question about the population. So what's the initial value here? Of course, everybody, this is the initial value. What's the growth rate? It means by what percent is the population increasing every year? Okay, every year. This is the growth factor. So that's the B. 1.026, that's the B. And the B is, no, be very careful, Jessica. That's the B. This is 1 plus the growth rate. Okay, so the growth rate is how far away is 1.026 from 1. That's really what the growth rate. How far we are from the 100%. So the growth rate is 1.026 minus 1. How far we are from 1, which is 0.026. Please be very careful with the growth rate. It's how far is the growth factor from 1. So this is 0.026. It means, what means to us, means the population is growing. By what percent? Means the population is growing by 2.6% every year. Okay, 2.6% every year. Okay. All right. Now look at number 3, and then number 3. And I care a lot about number 3. When I say something I care about, it means I put it on my quizzes and exams. We have the following scenarios. A population has size 5,000 at t equal to 0 with t in years. So at t equal to 0, 5,000. And P of t is the population in the year t. So time goes by, the population changes. And I'm going to give you 2 different ways the population change. And the question is find a formula for each one of them. Suppose the population decreases by 100 people per year. Find a formula for P of t. Okay, you have 1 minute to put the formula on the board, on chat, and then tell me what you did. Read the problem very carefully. We're graphing a little bit. We're starting at 5,000. Every year, the population goes down by 100. What's the formula for the population? No. Be very, very careful. Read the problem. That's why I'm giving it to you. It's A, not B, what we are doing. Every year, the population decreases by 100. So we start at 5,000, it went down by 100. Then it's going to go down by the same amount. And then it's going to go down by the same amount. What's the formula? Question number 1, is this linear decay, linear or exponential? This is the function decreasing by 100 people per year. Does this represent a linear model or an exponential model? Back to you. Linear or exponential? Linear, very good. If it's linear, it's linear. So what's going to be the formula? What's the slope here? What's the slope? That's the time, and that's the population. If it's linear, so the formula is going to be P of t is going to be mt plus b. That's what linear tells me. That's the formula that governs the population. But now what's the slope in this scenario? The slope is by how much we're going every unit. So the slope is going to be minus 100. And the b is my initial value. So in this scenario, the formula for the population is minus 100t plus 5,000. So be very careful with the kind of question we have. It's decreasing by 100 every year. Means it's going by the same amount every year. This is absolutely the linear scenario. That's the linear scenario, and that's the slope. Go 1, go down by 100. So the slope is going to be negative because we're going down. Go 1 over, we're going down by 100, and so on and so forth. So the formula is mt plus b because it's a linear decay. Now b. The population decreases by 8% per year. Is this linear or exponential? Is it going to be decreasing by the same amount every year? If it's going, that's the typical exponential scenario. It's not decreasing by the same amount because what's happening here? The population, scenario that I've of course talked about, it starts at 8%. After 1 year, it's going to decrease by 8%. So it's going to decrease by 8% of 5,000. Now, 8% of 5,000, it means it's 5,000 times 0.08. So it's going to decrease by 400 after 1 year. So right now, my population is at 4,600. Another year, it's going to decrease. But now it's going to decrease by 8%, not of the initial amount, of the 4,600. So it's going to decrease by a lesser amount, which is going to be times 0.08, which is going to be 368. So the population is definitely not decreasing at the same rate. That's a typical exponential decay. And now what's the formula for it? What's the population? It's the initial times b, the power t. B is the growth factor. Now what's my b? To find the b, I need the growth rate. So here, the growth rate, we have a negative growth. It's minus 8%. Minus 0.08. It means my b is 1 minus 0.08. It means 8% goes, so every year 92% remain. And then the formula for the population would be 5,000.92 to the power t. So be very careful with those type of problems. If your function decreases by exact the same amount every year, that's a constant decrease by the same amount, that's linear. It means this is the formula, mt plus b. If it decreases by the same percent, and then exponential decay, and that's the formula for the exponential decay. So we have to be very careful with the scenario that's put in front of us. Okay, now I look at number 9 point, which one? Which one, Leah? I forgot. Problem 7. Okay. So now we're going to look at the following type of problems. Last time we talked about, again, linear and exponential. And we say in the linear scenario, when x increases by 1, the y value, you add the same amount to the y value. In an exponential function, when x increases by 1, the y value is multiplied by the same thing. So with this in mind, we're going to look at 3.2. And I think Leah is asking me for number 7. I think so. And number 9. All right, so number 7. We have the following function. X, f of x. And it takes 2 to 10. And it takes 3 to 4. And it takes 4 to k. That's the output. Okay. And the question is, question number 1. Suppose f of x is linear. Means when I'm going to sketch the graph here, I have to get a line. Find k without finding a formula. Okay, so assume it's linear, find k. So it's sending 2 to 10. It's sending 3 to 4. And it's linear. Okay. So I don't know where it's going to send 4 to. We have to see. Find k. I give you a minute to do that. So I guide you. X increases by 1. Okay. If it's linear, it means the y value will be increasing by the same amount all the time. So what's going to be the k without finding the formula? Okay, everybody's telling me -2. Let us make sure. From here to here, the y value is going down by 6. If it's linear, it means it has to go down by the same amount from here to here. So from here to here, it's going to go down by 6. So what's going to be my k? K should be 4 minus 6, which is equal to -2. So in the picture here, if this is going to be 4, my k is going to be somewhere here. That's the 4, and that's the k. Okay, so we're going down by 6. We're going down by 6, by the same amount. Now, B. Let us assume this is the same graph. So I'm going to put, sorry, the same function. But suppose it's exponential. Then 4 and k. But now f is exponential. And we have to find k just by trying to understand how things work. So my graph right now is like this. At 2, again, I am at 10. At 3, I am down here at 4. And at 4, I am somewhere that I really don't know. And this is an exponential function, so the graph is going to look somewhere like that. Okay. So the question is, find k. Exponential, it means when we increase by 1, the output should be multiplied by the same thing. Multiplied by the same thing. So the question is, what is 10 multiplied by to give me a 4? Anybody has any idea? So what is the multiplier? How can I get from 10 to 4? What should I multiply by? Anybody would know? What should it be? I divided 2/5, Cindy 2/5. All right, so let's see how your classmates are finding it. So this is my question. That's my interrogation mark. So let's do it in a very systematic way. 10 times what, basically, will give me 4. That's really what I am actually looking for. What shall I multiply 10 by to give me a 4? So I find it. So this is going to be equal. I divide by 10. It's going to be 4/10, or 2/5. So it's not 5/2, it's 2/5. So what I should multiply by is actually 2/5. How did we get it? It's basically, what should I multiply 10 by to get 4? I should multiply it by 2/5. If this is the case, it means from here to here, I need to multiply by the same amount. So from here to here now, I should multiply by 2/5. So now what is my k? 4k should be the previous value, the one a little bit before it, times the 2/5. Now we're multiplying fractions, so we'll multiply across. This is going to give me 8/5. And that will be the value of k. So at 2, you are at 10. At 3, we are at 4. From 10 to 4, we're multiplying by 2/5. And then for 4, what this should be, I should take 4 and multiply this by 2/5. And this will give me the 8/5. All right? And this to emphasize the difference between exponential, you multiply by the same number because it's a times b to the x. Every time you multiply by b, when we go from one value to one value, which is 1 unit after it. All right, so we finalize this with number 9. And please, all of you try to do it, to see if you can do that. So this is the table. X f of x. And at 5, 2/3, at 6, a 3/4, and at 7, it's k. And the question is, f of x linear, find k, and then f of x exponential, find k. And I'm letting x increase by 1. So the question is, if it's linear, what am I? So 2/3, 3/4. So what am I adding here? And the same thing should be added right there. So the question is, what am I adding or what am I subtracting? Whether depending whether increase or increase. What should I add to 2/3 to get 3/4? Okay. So the question here is, because it's linear, the question, what did I add to 2/3 to get 3/4? Because that's linearity. What is the slope, basically? I'm computing actually the slope in this case. So somebody is telling me 1/12. So let me see where Jessica is getting that. So we solve for it. You get 3/4 minus 2/3. Now common denominator, 3 times 3/4 times 3 minus 2 times 4/3 times 4. The common denominator is 12. This would leave me with 9 minus 8/12, which is 1/12. So what I should add is the 1/12. That's not the k. So this number here is plus 1/12. So I should add here 1/12 as well. So what's going to be my k? Is the previous value, add to it 1/12. And again, a common denominator, I will have 3 times 3/4 times 3. And this will give me 9 plus 1, right? I'm getting 10/12. Anybody getting 10/12? So I have to add 1 over 12 to 3/4. So common denominator, multiply by 3, multiply by 3, which give me 9 over 12, plus 1 over 12, 10 over 12. Anybody has issue with 10 over 12, which could be simplified, of course, to 5 over 6, but it is 10 over 12. Now suppose it's exponential. The same problem is exponential. What should be k? Okay. 5, 6, 7, and 2/3, 3/4, and k. And f is exponential. What is the k? So the question is exponential. It means what should we multiply by from here to here, and the same thing should be multiplied there. Okay, watch what this number should be. How can I figure it out? And then I proceed. I don't want you to guess. I want you to be able to do it. I want all of you to do it. I'm going to ask one student in class to do it for me. I don't know which one. I'm going to pick one. And you have to do it. Think about how I did that. Okay, now I'm getting more explanation. That's what I want. Okay, Nick Martinez, your bad luck. Are you with me? Nick? Okay. If Nick is not there, I move. Tristan, are you with me? Okay. If you don't answer, it means you're not there. Zach Wilson?
Yeah, I'm here, but I'm looking at Cindy's message and I'm trying to see how she did it because I'm not sure.
Okay. Watch how she did it.
Uh-huh.
The question is, this is 2/3, right?
Right.
The question is, you need to multiply it by what to get 3/4? Did you see the setup I did?
Oh, yeah.
Did you see the setup?
Yeah,
I
I
want
think
all
so.
of you to see the setup. So how can you find the interrogation mark? You can divide by 2/3 both sides. We're going to divide by 2/3.
Okay.
Are you with me so far? I mean, I'm
Yeah.
addressing the whole class, but I have to, pick one student to make sure the whole class would follow.
Yeah, I understand.
Okay, now what do we get? It's 3/4 times 3/2, right? Fraction divided by another. You multiply by
Okay.
3/2. Now, what does we multiply fraction? You multiply across. 9, 4 times 2, get 8.
Okay. Yeah, now that I see you write it out like that, it makes sense to me. Thank you.
Sure. Now, what's k though? Since it makes sense to you, let's see if you can figure out k, all of you. So that's the multiplier. Basically, that's the b, if you want, in the exponential form. That's the b we keep multiplying by. Now I want k. I want all of you to give me the k. Again, look at the picture and make sense out of it. Okay, how can I get the k if it's the same multiplier? What this should be? Okay, now I know that I have answers, but I would like to pick on the student who don't put answers. So just to be mean a little bit. So let's see. Hunter, are you with me? Hunter. Okay, usually I move if the student doesn't answer. Jared, are you with me, Jared? Okay.
Yeah, I'm here.
Okay, can you tell me, help me out?
So wouldn't you just take the 9/8 and multiply it by 2/3?
No, multiplied by what? Be careful. I want K.
Oh, so you multiply it by 3/4.
Right, I multiply by the term before it, because that's how exponential work. If x increase by 1, it means the y value is multiplied by the same thing. It means every value is obtained from the one before it, multiplying it by the 9/8. So the K is going to be the value before times the 9/8. And now we're multiplying two fractions, multiply across. 27 over 32. Okay. And the goal of those problems is really to make you slowly better understand how exponential behave. So in the exponential format, we multiply by the same number when x increases by 1. But in the linear, we add the same number when x increases by 1. Any other questions? Okay, thanks for those who ask questions. Now there is still one thing I want to talk about concerning exponential before I actually move on to chapter 4, which is our last chapter. So a little bit I want to talk about the graph of the exponential because I think that's 3.3, I forgot. So graph of the exponential function. I indirectly drew it a lot of times, but now I want to make it very clear how it looks like. So an exponential function has the form a times b to the x. Now the growth factor b has to be positive. It means we cannot have a negative growth factor. The function does not make sense if b is negative. Let me give you an idea why it doesn't make sense. So suppose like I have f of x equal, suppose I will write something like that. Minus 4 to the x. Okay? Why this doesn't really make sense as a function? One of the reasons that this doesn't make sense is that suppose I tell you evaluate f of 1/2. What's going to be f of 1/2? Means minus 4 to the power 1/2. But what is minus 4 to the power 1/2? Means the square root of minus 4, which doesn't make sense whatsoever because we cannot have the square root of a negative number. So the growth factor, or the b, is always a positive number. So when we multiply by something, we always multiply by a positive number. So that's really important. So I don't want to see minus 4 to the x. It doesn't really make sense. Now, how's the graph of the function looks like? We're going to take two simple examples and use them to basically generalize. So suppose I take the function f of x equal 3 to the x. It means my b is 3, that's my growth factor, and my a is 1, because I didn't multiply it by anything. Now we're gonna graph this and make comment about the graph. Okay, let's graph it. I'm gonna take a bunch of values, x, f of x, and so far I always took positive values, but there is no reason why x cannot be negative. Actually, x can be negative. And that's really what I am adding to the picture now. All right, at 0, so this is my f, 3 to the x. My output is 3 to the 0, which is 1. And we knew that. That's the initial value, which is 1. At 1, 3 to the 1 is 3. And basically, we multiply it by 3 here. Going from one value to another, multiplying by 3. So at 1, we are at 3 here. 2 is 3 squared. So you realize this has nothing to do with linearity. From here to here, we went by 3. From here to here, we're going by 6. So linearity is nothing to do into the picture. So this is 9, which should be somewhere a little bit more actually. So at 2, I am right there. Now, what is the value at minus 1? At -1, it's 3 to the -1. But what's 3 to the -1? One of the main reasons we studied those negative exponents is basically to be able to talk about those ideas. This is 1/3. So at -1, my function is right there. It's very small. -2 is 3 to the -2. It means 1/3 squared. It means 1/9, even smaller. So at -2, my function is going to be right there. And -3 is going to be even smaller. So the graph is going to look like this. It starts very close to 0, very, very small value. It's going to increase, definitely not in a linear fashion, exponential fashion. Okay. Now, comments about the graph. One of the most important comment I want to say is, what's the range? And I'm bringing up the range for a reason. What does mean the range? It means what are the output value of the function? So the function 3 to the x. What are the output value? Question number 1. I don't know. You guys answer. What's the range? It means what are the output value? The range are all the output. All real number. The range. Do you agree with Jessica? Do you agree with Jessica? Yes? All right. If you tell me all real number, it means -1 is an output value. So now my question is, can -1 be an output value? Yes or no? It means, can 3 to the x be negative? What do you think? Is there a way I can raise 3 to a power and get a negative number? Watch it carefully. If x is positive, 3 to the 0 is 1, positive, positive, positive. When the power is negative, be very careful. The number is not negative. It's 1/3. When it's -2 is 1/3 squared. So 3 to the x can never be negative. So a number to a power, the exponential, can never be negative. Can 3 to the x equal to 0? Question mark. Do we ever have the value 0? Again, you have to watch what's happening. 3 to the 0 is 1. 3 to the -1 is 1/3. Also not. It's very important to understand that for the exponential. It can never take the value 0. It can never be negative. So what's going to be the range? It means what are the output values? All the positive number, not all the real number, only the positive number. Okay, so exponential function, that's their graph. They can never take negative value and they can never take the value 0. That's how the exponential function works. Now, before I generalize, I still have to take one situation, then I'm going to generalize the graph once and for all. Now, suppose I take an exponential, but I'm going to take the b less than 1. So we agree that the b has to be positive. Now, suppose I take another exponential, and I let my b to be less than. So I'm going to take 10 times a half to the power x. My b is a half in this case. How will this affect the graph of the function? This is x, this is f of x. Okay, and let's see how it's going to affect the graph. Again, I'm going to take values 0, 1, 2, -1, -2. And my output is 10 times a half to the x. So how the graph will be affected? At 0, it's 10. At 1, it's 10 times a half. So this time, we're multiplying by a half. Means the numbers are going to become smaller. So at 0, I am at 10. At 1, I'm halfway through in this particular scenario. I am at 5 because I'm multiplying by a small number less than 1. I'm making things smaller. At 2 is 10 times a half to the power 2, which is basically, again, I'm multiplying by the half of what I had before. So at 2, it's basically a half. It's going to give me right there. At 3, we're going to be here. Now, at minus 1, what's going to be the value at minus 1? It's 10 times a half to the minus 1. Now, we've seen this before. Try to memorize. It's actually 20, because every time I'm multiplying by a half, if this is 10, the one before it should be 20. So I am at 20. And then I'm going to be back here. So the function is going to go like that. It's going to go down, and skip like this. Because every time I'm multiplying by a half, I'm making it smaller and smaller and smaller. And now, like before, the range is always 0 plus infinity, and it's decreasing. What's making it decreasing is that the number I'm multiplying by is less than 1. So the numbers are, the output is getting smaller, because the number is, every time I'm multiplying in this case by a half, so I'm making the number smaller. I multiply by a half, I'm making this number smaller, which caused the function to be decreasing. So in general, what's the graph of exponential? So, suppose you have f of x equal a times b to the x. And then the graph will depend on b. If b is greater than 1, the graph rises. It means the graph rises, function increasing. So it's the b which tells me what's really happening. Now, if b is less than 1, but always positive, then the graph is going to fall, function decreases. You're going to have this kind of a picture. So when I have an exponential function, we know immediately whether we're rising or we're falling, and this really depends on the b, bigger than 1 or less than 1. So now the minute I give you an exponential, even though I don't ask you anything, so I tell you 10 times 1.2 to the power x, immediately I say, okay, my b is 1.2, bigger than 1, I have an increasing function. If f of x equal 10.92 to the power x, my b is less than 1, immediately I know that we have a decreasing function. Okay, so that's the graph, and that's the effect of b on the graph. Right. But now we're going to move to chapter 4, and the logarithm. So we're going to introduce a new function, a new rule called the logarithm. Before I introduce it, I have to tell you what's the purpose of it. I mean, why we're going to study this weird function, because it is kind of weird, and what's the goal for it. So suppose I tell you, I'm giving you a simple example. Solve 2t plus 3 equal to 4. Okay, big deal. You isolate your t. 4 minus 3, you divide by 2, you get your t. Very easy to solve. Suppose I tell you solve t to the power 4 equal to 7. Again, there is something called the fourth root of 7, which will solve the problem. But now the question here is the following. Suppose I tell you solve, watch how the situation is. This is a t, 1.2 to the power t equal to 7. I mean, I need to solve an equation where the unknown is a power. And that's problematic. I have no idea what to do in this scenario. So if I tell you solve this, the question is, what's t? Those problems are hard. We don't know what t is. So the goal of this new function that we're going to introduce today is to help me solve those type of problems. Okay, so that's really the main goal of this function. And that's why I've actually triggered people to start thinking about ideas. What can I do to solve a problem like this? And that's really the goal of the logarithmic function. So let's do that. So chapter 4, logarithm. Okay. So the logarithmic function. So we're going to introduce a new function, means new rule that will eventually help me to solve those type of problems. So I start with the definition, which is weird, unless you guys know it, and then we proceed. So definition. Okay. We're going to define something called log of a number. Something new, a new function. So let's see how to define it. So I say let n be a positive number. And positive is important, as I will tell you in a minute why. We understand why I put this restriction on n. Then the log of n, so it's a new rule, a new function, denoted by log of n is defined by. So what do this new thing called log of n mean? Log n is defined to be the power, it means the exponent, the power or exponent of 10, which is weird, that gives n back. The log n is the exponent of 10 or the power of 10 that gives n. So I'm going to explain it, of course, a lot. So what is the log of n? It's the number. It's a number that I'm going to call it a box that has the following property. So it's going to be the thing, is a number that has the following property. When I take 10 to the power of this box, I get n back. Okay, one more definition and then we start. So in short, log n is the thing, means 10 to the power this is equal to n. Okay, now let us practice this definition quite a bit. So the log of something is defined to be the power of 10 that gives me what's inside. So let us proceed. So practice. All right, let us find the log of 100. So I picked a number, 100, asking you to find the log of 100. What does this mean? What does this mean? Log of 100 is the thing or a box, such that if I take 10 to the power of the thing, I get 100. So the log is going to be a rule, a function. You give it an input 100, you give it this input, and the log is this machine that to 100 is going to give you the power of 10 that gives 100. We can think of as this rule, and that's what the log is. All right, which power of 10? Give me 100, and now it should be easy. I want the answers right now on Brightspace, because, on chat. Which power of 10 give me 100? Okay, the power of 10 that gives me 100 is 2. It means this is equal to 2. So the log is the power of 10. That's what's confusing about it. So we're going to play this game quite a bit. What's the log of 1? It means the log of 1 is the thing What should we put here? So that 10 to the power the thing will give me 1. So the question is, please don't use your calculator at all. Put your calculator on the side. I want answers without a calculator. I mean, I cannot see you, so you can do that, but please be honest with yourself. It means 10 to which power give me a 1? Of course, 10 to the 0 give me 1. So log 1 is equal to 0. So that's really the definition of that. Okay, let's do some more. Basic ones. What's the log of 10? Means 10 to which power? Give me 10. Big deal. 10 to the power 1 is equal to 1 because of that. Okay. Now, what's the log of 1 over 10? It means, again, it's the thing. It means 10 to which power? It's going to give me 1 over 10. Minus 1, Brianna, is she right? Yes, because 1 over 10, that's why, as I said, we studied those negative exponents. They're going to haunt us till the end of the semester. This is minus 1. Okay. 2 more, and then we move on. What's the log of 1 over the square root of 10? To which power? Give me 1 over the square root of 10. Let me pick a student. Amanda T, because I have 2 Amanda. Are you with me? Okay, Amanda Zach, are you there? All right. Brandon O.
Yeah, I don't really understand.
Okay. What should be 10 to which power? Give me 1 over root 10. Let us remember what's 1 over root 10 is. It's 10 to the power a half. That's what the root 10 is. Now, that's what the square root of 10. But that's what 10 to the half means. It's the square root of 10. So 1 over 10 to the power a half, our definition, this is 10 to the minus a half. So 10 to the minus a half is basically, so this is 10 to the minus a half. That's the definition. 10 to the minus a half by definition is 1 over 10 to the half. The definition of 10 to the power half is the square root of 10. So this is going to give me minus a half. Let me give you an easier one.
I'm just confused on how you get the negatives on how that operates still.
Okay. So why don't you stay with me at the end of the hour then?
Okay.
I'll explain it. Absolutely. Okay, I'll explain it. What's the log of 1 over 100? Grace, are you with us? Grace?
Yes.
Okay. Do we have any feeling for it?
Would it be 10 to the negative?
So that's 1 over 100. 10 to which power gives you 1 over 100?
2, so negative 2?
Exactly. Negative 2. So log of 1 over 100 is, honest to goodness, negative 2. Because 10 to the minus 2 is 1 over 100. So don't be afraid. Just use the meaning of it. Just totally interact with the meaning of that. All right. Now let me ask you the following questions, all of you. What's the log of minus 1? Again, go to the definition. It means the log of minus 1, so that's the input. The output, it means what it should spit out should be the power of 10, which gives me minus 1. Okay, Brandon, you're absolutely correct. It's absolutely undefined. Why it is undefined? Because 10 to any power is a positive number. As we said a minute ago, 10 to the power x is always positive, no matter what x is. It means we cannot find a number x so that 10 to the power x is -1. So this is absolutely undefined. Because we cannot find a number such as 10 to this power. The output of ln, it means what of the log, what it's going to give you is the power. So the question is, can you find a power of 10 that gives you -1? And absolutely not. So this is undefined. So the first thing tells me that the log of n in general, sorry, not the log of n, is defined only when n is positive. Is defined only when the n is positive. It means the input, what we put here, has to be a positive number. Otherwise, it doesn't make sense anymore. Okay. I'm going to keep working with the same ideas, and now I'm going to ask you a different type of problem just to interact fully with this log ideas. Practice. My question is the following. Rewrite each equation using exponent. First, what do I mean by that? And then I will let you write it. Suppose I take my calculator, for example, okay? And I evaluate the log of 15. Now, finding log of 15 is fairly hard for us. So let me talk a little bit. You don't have to write everything. Suppose I tell you find the log of 15. Okay, without a calculator for a second. What does this mean? It means I'm asking my student 10 to which power will give you 15? This is a tremendously hard problem because I don't know what the power is. It's not 1 because 10 to the power 1 is 10. It's not 2 because 10 to the power 2 is 15. So it's somewhere between 1 and 2. That's what it is, somewhere between 1 and 2. I don't know really exactly what it is. I can try. Okay, I say, okay, is it 1.5? I don't know. So we pick up our calculator and we take it to the power 1.5. Okay, I'm getting 31. It's not correct. So finding log 15 is a fairly hard problem. The one I gave you is really easy because I'm looking for the power of 10, which gives you 15. That's why to find the values of the log, we have to use our calculator. They have a special algorithm that will allow them to write the log 15. So now I pick my calculator and I just plug in. So the calculator have the log button, and I'm sure all of you, that's the log button of 15. Okay, I want all of you to make sure we know what it is. And I get 1.176. Okay. Now, rewrite each equation using exponent. It means I want the following. It means that, what does this mean? So you plug in this stuff and you get that. It means that if I take 10 to this power, you get 15. So that's really that definition. So the output of log 15, you can think of this as an input. The output is 1.176. The output is the power of 10 that gives me 50. So that's what we mean rewrite as exponent. So let me take another example. Suppose I take my calculator and I plug in the log of 200. My calculator will give me in something, 2.301. And the question is to write this using exponent. What does this mean? And the goal is to help us understand the meaning. What does this stuff mean? So this number represents what? This number represents the power of 10 that gives me 200. That's what the log 200 represents. It means if I take the calculator and I take 10 to the power 2.301, I should get almost 200. So we got 199.98, which is almost 200. That's really what the 200 represents. Okay. Let me give you one a little bit more abstract. If I tell you log of t equal to 4, how can we rewrite this using exponent? So you think of t as the output of the input of the log, 4 as the output. Who feel comfortable writing this using exponent? And what does it mean, log of t equal 4? Be careful, Leah. What does it mean? It means if I take 10 to the power 4, I get t. So that's really the meaning of that. Log t equal to 4, it means 10 to the power 4 is equal to t. So the log is the power, is actually the power of 10 that will give me the t back. Okay, so I ask you now the following question. It's a bit hard, but suppose n is a positive number. Okay, then if I take 10 to the log of n, this gives me what? So I take n raised to the power log n. What does this mean? By definition, what's the log of n? It's the power of 10 that gives me n back. So 10 to the power, that is equal to n. That's by the definition. That's simply the definition of the log. So what do we mean by that? Suppose I take 10 to the power of the log of 2. That's really what it means. Log 2 by definition is basically the power of 10 that gives me 2. In other words, if you take your calculator and you take 10 and you raise it to the power log of 2, you get 2 back. Okay, that's really what it means. If I take 10 to the power log 3, I get 3 back. But that's exactly the definition. It's the power, log 3 is the power of 10 that gives me 3 back. So that's how we read this situation. And I can keep going on forever. 10 to the power log of anything, that's what it is. I try 5, you get 5 back. So it's not an easy function. It's a hard function. It's not something very easy. It's hard because I am defining it as a power. I'm telling you the log of 15 is the power of 10 that gives me 15. That's really what the difficulty is in this function. The question would be, why did you take the power of 10? Why you didn't take another power? And the idea is there is nothing really magical about 10. It's just a nice number. The other number that we're going to take next time is the number e that I will define. And we're going to talk about a new function, which is exactly the same idea, but instead of using 10 as a base, we're using what we call the number e that I will define and work with next time. All right, so I stop here for today. For next Tuesday, you will have a quiz. I know some students were asking me if you have a quiz. So the quiz is on Tuesday because I like to do lecture, then quiz. So quiz on Tuesday. And the announcement will be on Brightspace, so you know exactly what you're responsible for. Also, you will have online homework. The online homework is already due next Thursday. It means a week from today. Okay, and we still have the logarithm to cover. And the last day of class, we will actually review the material. Your final exam is going to be comprehensive. It means you'll be responsible for everything. For those of you who like to start reviewing, you have a lot to review. You have exam 1, you have your quizzes, you have exam 2. So for those who likes to review, you can get ahead and start. All right, any questions before I let you go?
Dr. Elias,